The Ambiguous Case by Gina Chrisman, Aaron Fong, and Nikki Kim. Dolph's golf problem. Dolph's ball hits his tee shot. The ball winds up exactly 100 yards from the hole. On his second shot, the ball winds up exactly 45 yards from the hole, somewhere in the circle shown in the figure. If Dolph's second shot went on a line 15 degrees to the right of the line to the hole, sketch on the figure the two possible places the ball could be. So first, draw a line from the ball, or point D, to the hole, point C, and label it 100 yards. Then draw another line from point D, passing through the entire circle, creating point A and point B. The point through the line intersects with the circle. Afterwards, draw two lines from point C to point A, and from point C to point B, which equal the length of the radius, 45 yards.
So now we have to calculate the two possible distances the shot could have gone. The values that we are going to use in our formula are D equals 45, A equals 100, C is our variable, and D equals 15. Then to calculate the two possible distances the shot could have gone, we use the law of cosines. So when we plug in the values, we get 45 squared equals 100 squared plus C squared minus 2 times 100 times C times cosine of 15. When simplified, 2025 equals 10,000 plus C squared minus 2 times 100 times C times the cosine of 15. When the equation is simplified, it is 0 equals C squared minus 193.185C plus 7,975. When solving for C, use the quadratic formula. So C equals the negative of 193.185 plus or minus the square root of negative 193.185 squared minus 4 times 1 times 7,975, all divided by 2 times 1. When this formula is simplified, C equals 193.185 plus or minus 73.624 all over 2. When solved, C equals 133.405 feet or 59.781 feet. And remember to round to 3 decimal places.
If Dolph's second shot had gone on a line 50 degrees to the right of the line to the hole, show by calculation that it could not have been within 45 yards of the hole. Sketch the path of the ball, illustrating your answer. First, draw a line from the ball, point A, to the hole, point C, and label it 100 yards. Then, draw a line to point B, a point outside the circle, and mark a 50-degree angle between the two lines. Next, draw a dotted line from point C to point B, and mark it greater than 45 degrees. In order to prove that the line from point C to point B is greater than 45, use the equation 45 squared equals 100 squared plus C squared minus 2 times 100 times C times the cosine of 50. When simplified, 0 equals C squared minus 128.558C plus 7,975. Then, solve for C by using the quadratic formula, so C equals the negative of negative 128.558 plus or minus the square root of negative 128.558 squared minus 4 times 1 times 7,975 all over 2 times 1. When simplified, the equation becomes C equals 128.558 plus or minus the square root of negative 15,372.841 all over 2. It is then found that no triangle can exist because the square root of a negative number is not a real number. What is the maximum angle at which Dolph could have hit his second shot and still have it come rest 45 yards from the hole? To solve the maximum angle that Dolph could have hit his second shot and still have it come to rest 45 yards from the hole, draw a line from point A to point C and label it 100. Then, from point A, draw a line tangent to the circle. The point where the line touches the circle is point B. Label the degree between the line AC and AB as X. Then draw a dotted line from point C to point B and label it 45 yards. Then draw a 90-degree marking because when a line is tangent to a circle, that line forms a 90-degree angle with the circle's radius.
To solve for x, use the law of sines. The equation will be sine of 90 over 100 equals the sine of x over 45. When cross-multiplied, the equation becomes 100 times sine of x equals 45 times the sine of 90. When simplified, the equation becomes sine of x equals 45 over 100. To solve for x, take the inverse sine of 45 over 100. When solved, x equals 26.744 degrees. So the maximum angle the ball could have gone is 26.744 degrees.
And that concludes our problem. The end.
The end. Yay. Yay.